Assalamualaikum and good day. We are from Engineering Team Project Group 41 presenting to you Artificial Intelligence Sorting Recycle Bin. The content will be covering 7 aspects, starting from the introduction to conclusion and recommendation. Our team consists of 5 members, who are myself, Dania, Ali, Brandon, Nasrullah, and Alia. For our introduction, recycling process involves 3 steps, which are collection and processing, manufacturing, and purchasing new recycled content products. To recycle, waste sorting is the main process of separating waste. The sorting processes are done based on its material and amount. Recently, artificial intelligence has eased the process of waste sorting. Programming are utilized to recognize specific recyclables and guide robots' arms over conveyor belts in recycling centers. Our problem statement is the lack of waste disposal bin that can sort recyclables correctly and save household space in the global market. Our objective is to design an artificial intelligence sorting recycle bin which can ease the process of correct recyclable recognition and sorting and can save household space using Fusion 360, TensorFlow, and OpenCV.
Moving on to the literature review part. The first one is manual sorting system, which was used in the industry through hand picking. It is one of the simplest and most effective way to sort the waste as it uses human eyes to distinguish different materials. However, over the years, it becomes impractical and too expensive. The operation also becomes less effective and less accurate due to limited labor ability and human error. Next is automated sorting technology, where it uses different stages of sorting machine. This technique has higher accuracy and higher productivity compared to human power as it utilizes machine, but this technology encounters some economic and technical problems, which include high capital and high operational costs. Other than that is Max AI robotic sorters. It is among the new approaches in waste sorting using artificial intelligence. Max AI robotic sorters utilize AI and robotic to replace the human effort in waste sorting. As it uses a visual identification system, the need of human to monitor and differentiate the waste has been eliminated. Next inspiration is Trashbot by Clean Robotics, that is paired with autonomous system that uses robotics, computer vision, and AI technology. It has high accuracy in waste sorting compared to human being, but the bin is big in size, hence not suitable to be used for household usage. It is also not affordable by everyone. For design thinking tools, first we use Google Form survey in empathize phase, then we use the Kipling method to analyze the result from the survey. We use the brainstorming tool to generate idea and list all the possible solution. Then we use the AutoCAD and Fusion for simulation to bring the conceptual ideas to life. The last one, we use the Google Form survey to ask the feedback and improvement.
For project planning, let's take a look at how we effectively used all 12 weeks as part of our project. The first 4 weeks were used to identify the problem and also brainstorm ideas as solutions, where the following week we finalized the idea, we proposed and received approval from our supervisor, where we promptly distributed tasks based on our course disciplines. In week 6, we prepared the e-poster and also the video presentation, where in week 7 up to week 10, we finalized the 3D drawing and also the bill of materials used as part of our project. Week 11 and week 12 were used solely for finalizing the final report and submitting the e-poster and video presentation. All the members of our team played equally crucial roles in our project. Dania did background research as well as analyze problems and solutions of the product. Alia did literature review and product inspiration research. She also conducted surveys, pre and post design concepts. Brendan generated mechanical designs, researched mechanical tools and also materials for the product. Ali Ashraf Me generated electrical design as well as researched AI training and did some AI training themselves. Nasrullah reviewed the results, did recommendations, and analyzed capital and operational costs. Moving on.
Next, let us take a look at the design selections for mechanical parts. The AI sorting recycle bin is designed for indoor usage. The size is compact, where it is only 85.5 cm tall and have base radius of 35 cm. The colors selected are black and grey because it can harmonize well with other furnitures with different colors. This can be seen in the picture where the recycle bins fits well in a room. This is the engineering drawings of the design. The important dimensions, which include the tall and width, have been mentioned earlier. As we take a look at the sectional view, we can see that the frame is divided into 4 parts, where it will be explained later in the design concept video. This is the part drawing for robot arm, where the length is 18 cm, width is 19 cm, and tall is 19 cm. Next, let us look at the exploded view. The design have 13 components. The body of the design are made of high-density polyethylene, which is a common plastic used to make dustbin. It is chosen because it is strong, affordable, and light. For the small and machinery parts, PLA filament is chosen where they are 3D printed. This is because we want to produce a precise yet affordable model.
Moving on to the electronics design selection. We chose the following two main electronics, which are the Raspberry Pi and also the Pi camera module. The reason being is that the Raspberry Pi is capable of AI operation, where it can receive a camera input, in tandem with microprocessor operation, where it will be controlling stepper motors via a motor driver. Now, the aforementioned AI will be the one controlling the microprocessor controlling the stepper motors. Now, the AI will be running off of TensorFlow and OpenCV libraries, which is coded exclusively in Python. This is the Python code that allows it to do object detection. And this is where the pre-trained models allow the AI to identify materials based on the pre-trained model.
Now, I'll be presenting the engineering analysis. First, graphical analysis have been done where we applied the knowledge of linkage. The velocity, acceleration, torque, and force are being analyzed. So these are the calculations done based on each linkages. Finally, we found out that the maximum load that can be operated by the design is 11.84 Newton, which is around 1 kg. Besides, static test simulation have been carried out using Fusion 360 to test if the product fails under a 10 kg force. Finally, we get the safety factor of the frame is 5.465 and the robot arm is more than 6. Hence, it's proven that the design will not fail or break under a 10 kg force. For 3D printing, we use the software Creality Slicer to determine the amount of PLA filament required, where it is around 239 grams. The mass analysis is done using the software Fusion 360 and we get approximately 5 kg for the design.
For result and discussion, the design of our product is portable. It is light in weight and have a compact size for convenient household usage. The bin is affordable and should cost less than a budget smartphone. It is safe to use since it fully complies with HSE. And the bin also offers maximum outcome with a small budget. For economic consideration, I have listed the components of our product and its prices. The bin is estimated to cost around 385 ringgit. To conclude, the recycle bin was designated by using Fusion 360, TensorFlow, and OpenCV. It is designed based on the SDG 11, Sustainable Cities and Communities. The bin is targeted for indoor use as it provides convenient and also functionality for users. A post-survey has been done and received a good response from most of the respondents. For the recommendation, we suggest to use a higher torque motor as it can tackle more weight and install a user interface with intelligent assistant so that users can connect the bin to their smartphones. That is all from our group. Thank you.